So from the board layout, I like to do a discussion with you so that you can get a feel for what's happening. When we go to the rest of the training material and explain each circuit and things that are happening one by one, I want you to have an overall view of what we're dealing with. So let's get a couple of, we'll just call it phrases and etc. and locations, and we'll familiarize ourselves with that before we continue. Of course, starting with the power supply. Notice this power supply does include the ballast, so the ballast is not separate. Another thing that you can always note by looking at the ballast, the number of transformers, wow, I can't even talk, the number of transformers indicate the type of bulbs used. They're either EEFLs, I'll just type it in, so EEFLs or CCFLs. They're either external electrodes or cold cathodes. If you have only a transformer, two transformers, one for each side, then you're using external electrodes, EEFL bulbs. If you have a transformer for each bulb, that would be a whole slew of transformers, that would be CCFLs. We currently try to stay now with the EEFLs, and we'll talk a little bit more about those later, but the dead giveaway is just two small transformers. You have an AC input, which connects right to the power supply in the bottom right. But you'll notice there's another connector right there beside it that also goes back down like so. That's because this TV uses a master power switch which breaks the AC feed to the board. So it's a true vacation switch. Don't forget that when you're servicing it. And sometimes it's hard to know on and off, and I even have a slide that makes sure you know which way is what. It's the dot down, but it doesn't really tell you. Okay? So don't forget this does have a vacation switch. Pay attention also, you'll see a fuse and a fuse. The fuse I just highlighted is called the primary side fuse. Basically, you can almost see the entire dotted dash line around the power supply like that. Anything inside the dash line is hot ground. And there was a question from Dave about front LEDs. Please hold on, Dave. I'll give you all of that information shortly. The power supply has a hot ground side. Each one of these heat sinks are hot ground. This one to the top is cold ground. All right. When you first apply power, when you first apply AC power, the power supply enters the standby state. Everybody knows that. I want you to be aware of a couple of things. First, there's a communication cable between the power supply and, of course, the main board. In the standby state, there is only one voltage that is delivered to the main board, and it is standby 5 volts. That is the total output voltage supplied by the power supply at that time. Just one. In this set, there is no AC detect. In this set, the AC detect is not used, so you will not see it on that cable like you do in most everything else we've got. So that's one thing to keep up with and remember. Another thing is this. Connected at the bottom of the main board, all the way over to the left-hand side bottom, is all this viewed from the rear, of course, is a cable that connects standby 5 volts over to the front IR board as well. I'll put that in. Now we have the locations for the standby 5. It's feeding the main board and the front IR board. and that's it. So that's how we reach our Energy Star compliancy rating in standby. All right? Now, during this time, we have to deal with what's going on the main board side. Well, of course, standby 5 is down. I don't want to use the word converted. It's just regulated down. That's better, to 3.3 volts for the micro. Okay. And the 3.3 volts is used by that micro you see right there with the heat sink. That's also the video processor. And when the microprocessor then boots up and reset is released, that's all internal now to the board. Doesn't require the AC detect signal anymore to do that. The microprocessor begins communicating to the front control board via clock and data. I just want you to know this is answering your question, Dave. Does the set have standby LED in the front? Let me explain that because I think it's important for servicing. This clock and data goes over to the front control board and communicates with a front LED power LED driver. In this case, there are 10 LEDs that are utilized to indicate the status of power, and they turn on in different sequences to give a flow, they call it, of glowing transition. So it'll actually kind of dim out and look like it's going down as it changes states from red in standby to blue and run. So the bottom line is this. The standby 5 volts does not actually make the LEDs come on, even though it's used in making them come on. It is not what makes them come on. The controller chip on the front IR LED board is what makes the LEDs come on, and it must be receiving clock and data. And if it's not receiving clock and data, the front LEDs do not work. So that's a good clue for your troubleshooting as well. All right. Now that we're sitting there in that state, remember the front IR receiver is located where I just showed you at the bottom left. Okay. On the left side is a keyboard. And on this TV, that is where the power switch is located, the bottom key. If you hit the remote IR and tell it to turn on, or you hit the power switch, those are also routed all the way back to the main board, but those are sent back as what we call R2 ladder type voltage drops. And I'll show you how to read those and know what's happening later on. So let's say that you ask the TV to come on. The microprocessor generates the first turn-on signal, and that turn-on signal that it generates, it has a name that comes out of the schematic, okay? And on the schematic, it's called relay on. That's coming out of the microprocessor now. Now, that signal changes names when it leaves the main board and goes up to the power supply, and it changes name to PWR on. Relay on and PWR on are the same thing. I want you to note that the microprocessor creates relay on so that it can turn on other circuits on the main board. And one of the circuits it must turn on is something called a 5-volt general, and it's just a switch. It's a Darlington FET switch that changes standby 5 to a switched 5 once it's turned on, and that switched 5 is called 5-volt general. All right. And now, because I want you to know that, because 5-volt general is necessary to create another command that comes out of the microprocessor a little bit later. So let's just start with the power on first. When you tell the power on command and it goes up to the microprocessor on the power supply turns on and creates two voltages they go back down to the main board. 24 volts and 12 volts is sent back down to the power supply. Now, the 12 volts is used for video processing, and the 24 volts is used for audio. I want you to think about this 12 volts because I think this is critical. You can almost see the circuit. Look at the main board, top left side. You can almost see the IC right there. There is another IC switch right there, and in fact it's the same switch that created 5-volt general when you turn the TV on. That 5-volt general Darlington, it's not a Darlington in this set, it's a FET switch. The other side of it is switching something else, and that's the 12 volts. So the microprocessor now has to output another command. The TV is not on, and the backlights are not on. But I do want to explain the 12 volts first, and then I'm going to finish up with the power on command. Okay? The command that the microprocessor now outputs is panel control. The panel control command actually is routed from the microprocessor to that Darlington switch. And now the 12 volts that is input from the power supply is simply routed straight through and out the LVDS cable and all the way up to become TCON B+. So that is 12 volt LVDS, if I can type, 12 volt LVDS arrives at the TCON board. So that's how you get B+ to the board. So I want you to know that. The same 12 volts that was output from the power supply that fired up when you introduce power on is the same 12 volts that is used to drive the TCON board. So you need to know, how do I get my 12 volts up to the TCON board? And this explains it, and later I'll show you the circuitry. Okay, back up one step before that panel control command. Remember when power on arrived at the power supply, it kicked off the 12 and the 24 volts? It also turns on a secondary voltage side over here. That if you were reading that fuse, you would see it nearly triple in voltage. But what it does is a 105 volt DC supply is generated, which actually drives those FETs that fire up the transformers. But the transformer at this time is not being driven. It's just being given B+. So not only does power on turn on the 12 and 24 volts to the main board, it turns on the internal voltage for the ballast. But the ballast is not on. Okay? The next command that leaves the microprocessor and goes up to the power supply is a command called INV on, inverter on. That now energizes the ballast, fires the ballast up, and output on the backlight cables. If you can see those, you got one to the left, and you got one that goes all the way over to the right. There's 1.2 kilovolts running at 64 kilohertz that arrive at the backlights, EEFL bulbs, to light them up. So in other words, all the bulbs, around 28 of them, about the size of a pencil each, all the way across the panel. And if you look, you can see the little white plastic standoffs. Those white plastic standoffs are actually supporting the fluorescent tubes. They're on the left and right all the way across. And the tubes fire off. Video is now released. Okay? Video is now released after mute is